Today we're going to talk about absolute value inequalities. Before we do that, we're going to review quickly the absolute value equation. So on your note sheet, you have a problem that deals with the absolute value of 3, and I'm going to ask you to just go ahead and graph the solution set as you see here on this page, and recognize that the solutions are -3 and 3. Okay, and as you need to in this particular video, you can pause the video and jot down any information that you need to that you think is relevant or important that will be useful for your classwork. Okay, and then today's work, we're going to take a look at inequalities, and we're going to start with a simpler inequality, which would be like the absolute value of x is less than 3. So if we remember our definition, which is that absolute value is distance from 0, we're saying that the distance from 0 is less than 3 units, okay? And so the solution set would be -3 is less than x, which is less than 3, and we have essentially an and situation or a conjunction, and it would look like that graphed. And then we could also express that in interval notation, which would be a parenthesis, -3, comma 3, close parenthesis. So we have less than or equal to inequalities, and then we also have greater than or equal to inequalities. And the idea is we're saying that the absolute value of x is greater than 3, which means that we're looking for all the points that are more than or greater than 3 units from 0. So we have the solutions, which would be x is less than -3, because that's 3 units more than, is more than 3 units from 0. Or x is greater than 3. And so we have this idea of a disjunction or an and statement. And today we'll talk about and review how to deal with that using interval notation. Okay, so now we're going to go ahead and take a look at some examples. And on the top of the back of your note sheet, after you've finished filling in all of that information, you have some kind of refresher or review pieces that kind of sum up what we just looked at on the slides, okay? And so we'll go ahead and we'll start with an example, and we'll talk about the steps for dealing with or solving these problems, okay? So if we take a look at that first example, that absolute value of 4x minus 8 is greater than 12, what we can do so that you can have a consistent method for solving all of these is to go ahead and break it into 2 separate problems, okay? So we are considering that either 4x minus 8 is greater than 12, or we have that 4x minus 8 is less than -12. Okay, so there's a couple things. I usually tell students rewrite the original without the absolute value, and then on this side you're going to remove the absolute value symbols. You're going to switch the inequality because you're making this negative. So just like you normally would when you're dealing with a negative and inequalities, you're going to switch the inequality. Okay, and then you would go through the process of solving each of these individually. So we'd go through our inverse operations, and we have 4x is greater than 20. Okay, and then we'll divide by 4. And so we have that x is greater than 5. And then on the other side, we're going to go ahead and add 8 to both sides, but this time I have a -12 and a +8. Okay, and then we'll go ahead and divide each side by 4. And so then I have x is less than -1. Okay, then we'll go ahead and we'll graph our solution set. So we'll make ourselves a number line, and on our number line we have 0, 1, 2, 3, 5, and then here we have negative 1. Okay, and we'll mark each of those points. So this one is greater than 5. And again, you can use the open circle, or you can use your parenthesis. Excuse me, this should be a parenthesis. Okay. And then x is less than negative 1, so we'll have our parenthesis here, and less than negative 1. Okay, and then we'll go ahead and we'll put that into interval notation. So on this side, we have negative infinity as our endpoint to negative 1, both exclusive. And on this side, we have a 5 and to infinity as the second endpoint. Okay, I'd like you to go ahead and pause the video, and I'd like you to try number 2. I will offer the first hint, which is to make sure that you isolate the absolute value. So just like we did when we were solving the equations yesterday and the day before in class, we're going to isolate the absolute value. And then once you have it isolated, then you'll go ahead and make your what they call derived inequalities. So you'll go ahead and deal with them in the same way you did here. Okay, so again, I'm going to ask you to pause the video, and I want you to go ahead and finish number 2. Okay, so hopefully you have some answers for number 2, which we'll go over with, tomorrow in class. We're going to take a quick minute to look at these last 2 problems. So we're going to follow the same process we did here, which is to isolate the absolute value. And now we have that 3d minus 5, the absolute value of that is less than negative 3. Okay, so is that possible? Is it possible for the absolute value to be less than a negative number? So in this case, that's not possible, so we have no solution, or the empty set. So if you were to try any value in here, you would find that it didn't work, okay, because we're adding this 7. Anything that's positive plus a 7 is not going to be less than 4. Okay, if we take a look at this one, it's a similar type of process. So we're going to go ahead and we're going to subtract that 7 from each side. This time we have 3d minus 5. The absolute value of that is greater than negative 3. And so in this case, we can, again, without doing any derived equations, answer this with limited work. Absolute value is always going to be greater than a negative number. So in this particular case, we have all solutions, which we would represent by negative infinity to positive infinity. Okay, so make sure you have that number 2 finished, and I will see you all tomorrow.